Hello again. In the previous lesson, we calculated determinants using Cramer's rule, and we used it to solve linear systems. In this lesson, we're going to look at nonlinear systems, and nonlinear systems contain at least one equation that is not linear. Examples include things like parabolas, circles, and other curved graphs. The solutions are the intersection points that satisfy every equation in the system. So what we want to do is look at the quick rules. All right. A nonlinear system is represented and it contains at least one equation that is not linear. So we're going to be using this equation here to find the x values as well. And instead of reading this, because this lesson is going to be a little long, you can pause the video and read that. But we're going to apply those rules in this lesson here. Okay, so the first one says solve a linear and parabola system. Notice we have y is equal to x plus 1 and y is equal to x squared minus 3. So what we can do here is we can essentially set these equations equal to one another. X plus 1 equals x squared minus 3. Then what I want to do is I want to move this over here, which is going to be x squared minus x minus 4 equals 0. Okay. Now it's important to note this quadratic does not factor using integers, so we have to use the quadratic equation. So the quadratic equation is x is equal to negative b. So I'm going to go ahead and actually write these out. So a is, in this case, 1, b is equal to negative 1, and then c is equal to negative 4. So I'm going to go ahead and compute this. So that's going to give me negative 1 plus or minus. So it's going to be negative 1 squared, or 1, and then plus, that'll be 16 divided by 2 times 1. Okay. So that essentially gives me, so this will give us 1 plus or minus root 17 over 2. So again, we have two x's here. So if we have two x's, then that means we're going to have two corresponding y's. So how do we substitute that? So the way this would look is we would have 1 plus root 17 over 2 for one value, and then we would have 1 minus root 17 over 2 for another value. So we would have to essentially substitute these into the expression here to solve for our y's. Okay, so I'm going to do that now. So if we use this x in here, we would have to create this, which would be 1/2. So let's see. So that's y equals 1 plus root 17 over 2. And then it have to be common denominator, so that'd be 2 over 2. So this would be 3 plus root 17 over 2. And then also 1 minus root 17 over 2. Plus 2 over 2, which would be 3 minus root 17 over 2. So notice I have those values, those corresponding y values. That's 3 plus root 17 over 2, and then 3 minus root 17 over 2. Okay, so that pretty much shows you that whenever you have a system that has two x's, you need to make sure that you find their corresponding y's. Okay, now what I can do is I can substitute the values into the equation and solve to see if the values satisfy the equation and if they're true. But this pretty much satisfies that we are done here. Okay, so again, what you need to do is substitute the x's into this equation here, and then this will compute the y, and then they do the same thing for the other, which would be the negative. So so you just keep in mind that this part is very, very important, because the x in this case generated two solutions. Okay, so that's something very, very important to note. And then input these into the equation and solve to get the desired order pair. Okay, very, very important. Okay, let's continue. So in this problem, we have x squared plus y squared equals 25, and then we have y is equal to 3. Check each solution in both equations. So thankfully, this is already set. So y is already set equal to 3. So what we can do is we can substitute that into the equation. So we have x squared plus 3 squared equals 25. X squared plus 9 equals 25. Subtract 9 on both sides. X squared is equal to 16. And then from there, take the square root of both sides. X is equal to plus or minus 4. So notice we got two solutions here. So x is equal to -4 and x is equal to +4. So the way we would check it is we have essentially 4, 3, and -4, 3. Because this is a circle, right? That's x squared plus y squared equals 25. So this creates a circle. What this is basically saying is that this point and this point is where that line is going to go directly through this particular circle. Okay, and we can check the solution. We can say, okay, 4 squared plus 3 squared equals 25. That's going to be 16 plus 9. So that checks out. 25 equals 25. And then we can also check the other point to make sure it satisfies. That's going to be a negative, which is going to be 16 as well. Okay, so they both check out. So it says check each solution in both equations, and they both obviously work. Again, the main idea is when you have two solutions of x, you must find both solutions of y as well. All right. So pause and try this problem below. Without fully solving, describe the possible number of solutions for a line intersecting a circle. Include the geometric meaning of each case. So essentially, what it's saying is you're going to have, these are your possibilities. You have either no solutions, one solution, or two solutions. So this means there's no solution, or no solution exists. This means that the line is tangent to the circle. And then 2 means that it enters and exits the circle at 2 points. Okay, and so this is for real solutions for a line intersecting a circle. Okay, so that's very important. So at 0, there's no solution that exists. 1 means that the line is tangent, and then 2 means that it intersects. Okay, so that's essentially looks like this. The line is going here, and then for this one, the line touches right here, passes it, and then for this one, the line passes through. Okay, let's continue. Example number 3, we have y is equal to x squared and x plus y is equal to 6. Okay, so what we need to do here is I'm going to, since this is already set equal to y, we can replace this guy over here. So what we will do is write x plus x squared equals 6. We would move the 6 over. So x squared plus x minus 6 equals 0. Now for this one, we can find a system, and that system would be two numbers that multiply to give me -6 and add up to give me a +1 would be 3, +3 and -2. It's going to be +3, -2. Essentially, that would be x plus 3 using the product power of 0. So setting it equal to 0. And we have x minus 2 equals 0. So this would give me x is equal to -3. And then x is equal to +2. So again, when you find two x values, you need to find their corresponding y values, okay? So what we want to do is we want to essentially substitute this value in for, so we have y is equal to x squared, y is equal to -3 squared, y is equal to 9. And then we want to do the same thing for the other one. Y is equal to x squared, y is equal to 2 squared, y is equal to 4. So as you can see, we have our corresponding x's and our corresponding y's. So the solution here would be -3, 9, and the solution here would be 2, 4. Okay, and then we can check the solution to see if it works. So let's see. So we have -3, 9 and 2, 4. So 9 equals 3 squared. That definitely checks out, right? Because 9 equals 9. And then we have -3 plus 9, which equals 6. That'd be 6 equals 6. So those check out. And we have 4 equals 2 squared, which satisfies the first equation. So just substituting 4 equaling 2 squared, that would be 4 equals 4. So that checks out. And then 2 plus 4 equaling 6, which is 6 equals 6. So they both check out perfectly. Okay, let's continue. Okay, so the revenue equation for this one is Rx equals -x squared plus 18x, and the cost equation is Cx equals 6x plus 20. All right, so what we want to do for this one is it says find the break-even production levels by solving Rx equals Cx. So this is basically saying set both of them equal to one another. Okay, so Rx we have -x squared plus 18x, and we're going to set it equal to 6x plus 20. There's a couple ways to do this, but I want to get rid of this -x squared since it's the highest power. So I'm going to I'm going to add x squared to both sides. And then I'm going to subtract this 18 over here to both sides. Okay. And once over here, I need to combine like terms. Notice this cancels and this cancels, and then combine like terms. So I have x squared, and then these two can be combined. 6x minus 18x would give me -12x. And then the 20 or the constant cannot be combined to anything. Okay. So that's using the process of elimination. All right. So, and then combining like terms. So this tells me that x squared minus 12x equals 20. Now, where do I go from here? I need to find two numbers that multiply to give me 10 or 20 that add up to give me -12. So I know that that would be -2 and -10. Okay. Using the zero product property rule, we would set both of these equal to 0. And then this tells me that x is going to be equal to a +2, and then that x is going to be equal to a +10. So I have both of my x values. Okay. And what we do essentially is we substitute those values into their respective equations. So we're going to use 2 in both of them, and then we're going to use 10 in both of them. So we substitute 2 into this equation here. Matter of fact, let me write it's x squared plus 18x. Okay. This is Rx, and then 6x plus 20 is equal to Cx. Okay, so I just want to keep a track of it so it looks correct to me. So this will be negative 2 squared, and then notice, just be careful here because the 2, I'm substituting the 2 in it, and the 2 is positive, not negative, so that negative would be outside of the parentheses. Plus 18 times a positive 2, that would give me 32. Okay, because this is 36, and then that would be negative 4. That's 32. Okay, and then C, substituting 2 for that as well. So that would be 6 times 2 plus 20, which is 12 plus 20, or 32. So notice we have a correspondence there. The revenue and cost are both 32. Now we need to check 10. Okay, so 10, which would be, again, that's a negative. Okay. So this would be negative 100 squared plus 18 times 10. Okay, that would be 100 or negative 100, and then negative 100 plus 180 would be 80. And then let's check the cost. So that would be 6 times 10 plus 20. So 60 plus 20 is 80. So notice what happens there. The revenue and the cost are both 80. Therefore, both production levels are valid breaking points. Okay, let's continue. So a student finds 2x values after substitution, but reports only one ordered pair. Explain why every valid x value must be paired with its corresponding y value. So again, a solution is represented by x comma y. So let's say, for example, let's say x is equal to 2 and x is equal to negative 3. Well, then what you need to do is you need to find 2 comma y sub 1, and you need to also find 3 or negative 3 comma y sub 2. Okay, you got to find the y values. Okay, you can't just find the x values and move on. So it says he found the 2 values after substitution, but reports only one ordered pair. Okay, so you can't do that. You need each respective value, because if you don't, then you won't have any, you won't have a complete system. When you're looking for every solution, the first thing you want to do is find x. Second thing you want to do is corresponding y's. Okay, and then you want to write the ordered pair. And then you want to check both equations. That is the sequence. Okay, so it's just very important that when you're looking for the common mistakes in these problems, that a common mistake is saying that, okay, I found one x, I can move on. No, if you have two x values, then you need to find two corresponding y values. And so use this as a reference. First of all, find the x or x's, then find their corresponding y's, or find its y, or find the ordered pair, write the ordered pair, and then check both solutions. That is the sequence. Okay. So just to recap, when you're using nonlinear applications or nonlinear systems and their applications, you need to find the x. You can use the quadratic equation. And you need to identify in that event, when you have to use that, what A, B, and C is, substitute it into the quadratic equation, solve for two x's, and notice if you have two x's, we had to find their corresponding y's by substituting the x values into the equation here. Okay. Then, and we use that equation, remember, because we could not use this one. This one was in quadratic equation form, so it was best to use that one. Then over here we have a circle, right? We have x squared plus y squared equals 25. And this one was already set equal to y. This is really nice. When it's set equal to y already, all you have to do is substitute that into its respective equation and then solve. Here we also looked at, in the event you have a circle, what does 0, 1, and 2 mean? 0 means no solutions, that there's no intersection passing on that line in the circle. 1 solution means that that line is tangent on the circle, and then 2 enters the circle at 2 respective points. Okay? All right, this concludes video 17, part 4, nonlinear systems and applications. Thank you again for watching, and I hope to see you in the next one.